So today in this class, we are going to talk about data types and constraints. So till yesterday, we have completed till create database. After that, I have told you about why we use database. And then we are on the topic like creating tables. Tables in database. And you all are aware about RDBMS, your SQL, like what is SQL and what is a server. These are the things that you are aware of. Like we have taken all these things in the yesterday's class. Now, from today, I told you that before actually creating a tables, we have to understand like what are the important things to create a table. For example, if you are going to cook food, you must need ingredients. You must need some kind of cooking utensil to cook your food. So if you want to create a table, you need something before actually creating it. So if we talk about the things that we need to create a table, there are two things that comes into the picture. First is data types and second is constraints. So what actually a data type is? Just tell me, if you want to store water, then in which thing, what is the thing in which you will store your water like in a better way? Like you can store water anywhere. The thing is, if you want to store your water, where you will store it? Just tell me in the chat box. Bottles, which is like water bottle. So now if you are talking about this thing like in a container, in a water bottle, so you know that there are specific type of things in which you will store some specific kind of values. So if I want to store water, I can store it in bottle, I can store it in tub, I can store it in there are different things where I can store it. So same like this, there is something known as data type. So data type is a type of container. Data type is a type of container in which you store some specific kind of values. So for example, if you want to store your name, in a table, so before actually storing your name in the table, you have to give your table column. Like there are columns in the table. So for example, if my table is employee, and in this employee table, there is a column name, and I want to put some specific kind of values in the name column. And those values will be like Durgesh, Mian, Abhishek, Shubham. These are some kind of values. But these kind of values are stored in some specific kind of containers. And those containers are known as data types. So there are different type of things. For example, if I want to store any alphabetical character, so alphabetical character like A, comma B, comma C, comma D. If I want to store any string kind of value, so what is a string? A string is basically, like for example, I am writing Durgesh here. So Durgesh is a string, and the length of the string is 1, 2, 3, 4, 5, 6, 7. So Durgesh is a 7-letter string. So if you want to store any character value, alphabetical value, string value, all these types of values are stored in a specific kind of container, and that specific kind of container is a data type, and the data type used for containing these kind of values is char, comma, varchar. These are the two things. So if you want to store any these kind of values, then you have to use char or either varchar. Both will store same kind of values, but there are some difference between both of them. That I will continue after some time. So now, suppose I want to store my name. What will be the data type to store my name? It can be either char, it can be varchar as well. Now, if you are using char, then when you are writing char here, there you have to put a open and a close parenthesis. And inside that parenthesis, you will pass how many characters it will hold. So for example, I will write 20. And here also I will write 20. So now, for example, if there is an employee table, and employee table, there are 100 employees working. So there are details of 100 employees. Can you tell me, like, how many character value you will take inside char? Like, what can be the value that you will take inside char or varchar to store 100 employee names? So all the employee names can be different. For example, if the name is Durgesh, Durgesh has 7 characters. If a name is Abhimanyu, it has more than 7 characters. If the name is Abhishek Pratap Singh, then it has more than 20 characters. So you have to take a maximum limit of characters in which you think that all your names will come. So you can take at least 30 because no name can be more than 30. If any name is exceeding more than 30, for example, you have an employee table, you created a name column, and to that name column, you have given a data type char 30. Now, if any element that will come inside your name column and will have more than 30 characters, you will get an error. The error that you will get is like you have given maximum limit of 30 characters and you're storing more than that. So this is kind of an error that you will get. So same for varchar and same for char, you have to give some limit there. In many of the databases, there is no limit. So if you are giving no limit, then it will take the maximum limit of the varchar or char character. Then it will take the maximum limit. So there is some maximum limit for both of them. So char has a maximum limit of 255 characters. And varchar has a maximum limit of 65535 characters. So if you are not giving this kind of thing, or if you are not giving this kind of thing, in some of the editors, they don't require this thing. But it's a good thing that you will pass. I will tell you why it's good to pass these things here. I will tell you that thing as well. What is the difference? Only space. Pooja, just wait for some time. Let me explain. You will get each and everything. And nobody have told you this thing previously. Like, just wait for some time. I will tell you everything. Let me finish this thing first. So yeah, so this is char and this is varchar. So it has a maximum character, maximum limit of this. Now, what is the exact difference between both of them? So now you know that if you want to store your name, if you want to store anything related to string or alphabetical value, you can use char as well as varchar. You can use char as well and you can use varchar as well. Then what is the difference between both of them? What is the difference between both of them? So suppose my name is Abhishek. For example, my name is Abhishek. Tell me, how many characters are there in Abhishek? 8 characters. So let's take an example. I have a name column. And in that name column, I have given a data type char 10. I have given a data type char 10. Now, if I'm giving Abhishek to the name column, it will fit, yes or no? Yes, it will fit there. Now, if it will fit there, how many character space I'm losing here? How many characters space I'm losing here? Two characters space. If I'm typing a name here, if I'm typing a name here, Durgesh ABC, how many characters are there? 10. Will it get fit inside the char 10? Yes, it will also get fit inside the char 10. But for example, if I'm writing Durgesh ABCD, now what will happen? It will give you an error that your limit is exceeding. Now, just take an example of the less characters. So you have written Abhishek, and Abhishek takes only 8 characters. So there is a missing thing of 2 characters that you are losing. You are losing the space of 2 characters because your name has only 8 characters. So if you are using char, and if you are giving it a limit of 10 or 20 or 30, and if you are not using that limit fully, in Abhishek's example, I am using only 8 characters. So 2 are remaining. So all the remaining units that you are not using, all the remaining spaces or all the remaining space that you are not using will get wasted. And you will see it like a padded space. So you will not be able to see it in the call. Like when you will run your table, you will not be able to see it. But in the back end, it will appear like this. Abhishek. So this is basically a padded space. So there will be 2 padded spaces. And it will appear like this. So you will only see Abhishek there, but there will be 2 padded spaces because you are losing 2 character space there. So in char, if you are using char 10 and if you are not using all the 10 characters, then all the remaining characters will get a padded space there and you will lose that memory. So memory wastage is there. Now, if we will talk about varchar, and one more question, just tell me if you know that in char there will be a memory wastage if we are not using it fully, then tell me what can be the thing that you can store inside a varchar, like inside a char. What can be the perfect thing to store inside char? You can store your phone number. And if you are storing your phone number like this, then your phone number is not a number. Your phone number is a string. So you know that phone number has only 10 characters in India. So if I am going to create a table in which Indian employees are there and I only want their phone numbers, so the perfect storage point will be char, because we will use the memory fully and we will not lose any character. And one more thing, char is faster. I will tell you why it's faster. When you will know the fixed length of thing, then you can use char, right? Correct. So now I will tell you why char is faster. But before that, we will take an example of varchar. What is varchar? So suppose I have given varchar 20 here. And I want to store Durgesh here. Tell me how many characters space I'm losing here. How many character space I'm losing here? 13. But in varchar, I will lose anything because varchar is a dynamic memory allocator. What it will do is, for example, if I am passing Durgesh to the varchar thing, it will automatically allocate 7 spaces to my name Durgesh. Like it will dynamically assign the memory. The max memory is 20, but it will assign a 7 space memory to me because my name has only 7 characters. So if you are passing a name more than 20 characters in varchar, more than 20 characters. In this example, if you are passing more than 20 characters in varchar, it will give you an error. You cannot pass more than 20. But if you are passing 16 letters name, then what will happen? It will dynamically assign a 16-letter space to your name and it will not waste any memory. But varchar is slower. So why varchar is slower and char is faster? Because varchar is actually doing 2 jobs. It's taking your data and it's assigning a memory dynamically. So it's doing a second task of assigning the memory dynamically. That's why varchar is slower and char is faster. So tell me, now my question is, this is the main thing that people will ask you in interview, the difference between char and varchar. So I told you the difference. Now my question is, when to use char, and when to use varchar. When to use char and when to use varchar. Char for fixed length, char for fixed length. Correct. If you have a fixed length requirement, then you will use char and it will be faster. If you don't have a fixed length requirement, then you will use varchar. Correct. So are you good with char and varchar? Can we move further? Okay. Now we know how to store, like we know why. Please explain dynamic memory. See, dynamic memory is a kind of thing. For example, there is a place of 10 chairs and 7 people are coming. So there will be a thing in backend. The backend, like you will not be able to see this thing. For example, you are going to a movie hall and that movie hall has 20 seats. But you are only 13 people who are going inside that hall. So before you are going inside the hall, people know that you have a 13 space memory. So what they will do, they will remove 7 chairs from there at the back end. And now when you will go inside, you will get a space of 13 places only. So that is something that is doing on a back end, on a dynamic nature, like automatic. It's automatic. That is something known as dynamic nature. Like what kind of more examples? It's very simple. Just understand. For char, like phone number is an example for char. In many places, like pin code, for example, you are talking, if you have a data of Bangalore, some location, if you have some data for Bangalore location and that has a proper pin code. So what you will do, you will take a proper, pin code has 6 characters. You will make a 6-character pin code there. So pin code is also an example. Date of birth is char. See, date of birth is not char, not varchar. Date of birth is date. They will tell you. Just wait. DOB is not char or varchar. It's stored like a char and varchar in inverted commas, but it's actually not a char and varchar. It's actually a date. Okay. Let's, after the string and alphabetical and all these things, let's talk about numbers. So if you want to store a age is a number. If you want to store a numerical value, if you want to store like 1, 2, 3, 4, 99, 100, anything in the numerical form. If you want to store anything in the numerical form, at that point of time, the data type that you will use is int. So int is basically known as integer. So if you want to store integer values, you will use int. So int is used for integer values. Is it clear why int is used? And int has a range. So don't worry about the range because you will not exceed that range. So it's like you can say, if I'll tell you 2147 million. So you can store a value up to minus 2148 million to plus 2147 million, which is basically you can store any value between these two values in int. Now, if your value is more than this, like this thing, more than this, if your value is more than this, then you will use big int. Big int is like a higher perspective of int. So if you have a value between this range, then you can use int. Like maximum 99% you will use int only. Big int is, you can also use big int if your value is more than this. So sometimes value is more than this. And I will recommend you, if you want to use int, so people don't tell you this thing, but I will tell you, if you want to use int, try to use int in numbers with whom you want to do some kind of calculation. So all the numbers with whom you want to do some kind of calculation, you have to store them in int. Now tell me, if I want to store my age, so I can store my age like this also in a type of string with the help of char or varchar, and I can also store my age like this. So if you have a requirement in which you have to multiply ages, adding ages, and different kind of thing, then you will use int for your ages. If you don't have any requirement of calculation with your age, try to drop your age in varchar or char. Now tell me, phone number. If we'll talk about phone number, you can store your phone number in int also, and you can store your phone number in char or varchar also. Which thing you will use? Tell me fast. You know that you don't have to perform any calculation with your phone number. So you will store it in varchar or char. You will not store it in int. So that is something I want to tell you. Now, you know about integer things. But for example, if your values are like this, 23.467, 45.768. So every time if you have some decimal kind of values, then the data type that will be used is float. So float is a data type that is used for decimal values. So if you have point values, which is basically known as decimal values, then you have to use this thing. Correct? It's clear. And for example, if you want to store a value, if you have written float as a data type, if you want to, for example, I want to store my salary. And you know that when your salary comes, it's never a round number. You will not get your salary as a round number like 90,000, 1 lakh, 2 lakh. You will always get your salary in the point format. Even if you are like, if you are taking them in hand salary, like directly from hand in hand, then it will like, it can be like a round number. But if you are getting your salary on your account, it will be always a floating number. So you can also, for example, if you are taking any column salary and in which you want to drop some salaried values, which will be decimal values, you can also specify something like this: size, comma D. So size will be your value before the decimal places, and D will be how many decimal places you want. But don't worry about this thing. You don't need this now. You just have to focus on float. So if you want decimal values, then you have to use float. Is it clear to everyone till now? Now we will talk about date, like date, timestamp, and all these things. So now, if you want to store any date, date of birth, date of joining, any date kind of thing, if you want to store any date kind of thing, then you have to use a data type which is known as date. So date is the data type. Now, if you want to store date along with time, date along with time, like this, I will tell you 2023, and date is always stored in a char or varchar format. It's not a char or varchar format, but it's always stored in a form of a string. So even if you are entering your date anywhere in SQL, you have to put it inside inverted commas because it is taken as a part of a string. So what I will drop my date here: 2023 01 01 00, like 12 a.m., 36 minutes, 45 seconds, and 9459 milliseconds. So this is a date time format in which along with date, you also have time. So if you want to store something like this, then you will use a data type which is known as date time. Then date time is the data type. And there is one more data type to store same kind of thing, which is known as timestamp. So now timestamp has a different story as well. So for example, if you are using timestamp while creating your table, if you are using timestamp while creating your table, and if you will not write a particular date time for timestamp, if you will not write a particular date time for timestamp, like for example, I have a date of birth column and I have specified a data type timestamp there. And if I don't want to write time there, it will automatically take the time when I drop that record. So for example, if I'm dropping that record right now, then it will take same record at the same time when I drop the record. So in date time and timestamp, in both of them, you can drop your own date and own time. But in timestamp, it gives you a single more functionality in which if you want to get a time when you enter the record, you can get that. So both date time and timestamp store date time values only. So both will store same values. You can store this value with date or date time also. You can store this value with timestamp also. Now tell me, what is the difference between them? If we store same values with the help of date time and same values with the help of timestamp, what is the difference? This question is asked in interviews, and people know tough things, but they don't know basics. So I will tell you what is the difference between date time and timestamp. See, date time is slower than timestamp. Date time is slow and timestamp is faster. Now, what's the reason? What's the actual difference between them? See, date time can take values starting from 9,999 to, sorry, starting from year 1000 to 9,999. Date time can take values from year 1000 to 9,999. But timestamp will only take values from year 1970 to year 2058. I think, sorry, 2038. So this is a difference. And it has a small range. That's why timestamp is faster. And this date time has a bigger range. So that's why it's little slower. So did you got the actual difference, like the difference between date time and timestamp? Is everybody clear till here? After 2038, we cannot use timestamp. Yes. It has a range of this thing only. Which is preferred? Like most of the times, if you see, if you have, like, for example, there is something known as data pipeline. So if you are a data engineer, what happens is, for example, your company is a sales company and they are doing regular sales. And now, for example, if you want to load those records from the same timing to your database, like for example, a sale has happened at 8 p.m. and at the same point of time, you are pulling that data inside your database. So now you don't want to write your time manually. At that point of time, you can use timestamp. So when that data or that event actually happened, you will get the same timestamp of that. So on a bigger perspective, if you are doing something like this in which you want your time auto updated, then you will use timestamp. Otherwise, you can use date time. So date time is preferred more. If you'll ask about preferred thing, like date time will be more preferred. So everyone clear till here? Like, are you understanding the topics? You're really understanding the topics? Are you getting the things? Okay. Okay, so let's start with, so these are the data types that are required for our analysis on a daily basis. And 95% of the things are covered within these data types only. And if we have some additional needs, that we will learn on the further lectures. Can we modify the timestamp? You can modify anything. It's better to take date time. You can update anything that is in your table. Even if it is a timestamp, you can update it. Let's take 2 to 3 minutes break. Just take, like, I have to drink some water. Just take 2 to 3 minutes break. Now, what do you understand by constraints? Any one of you? What do you understand by constraints? Normally, what do you mean by constraints? Just give me your answer in the chat box. Suppose you are creating your table. Suppose you are creating your table employee. And in that employee table, there are some specific columns like employee ID, employee name. And on your specific columns, if you want to drop some kind of rules. So basically, constraints are set of rules. So if you will talk in terms of SQL, constraints are set of rules that are applied on your columns to get some specific kind of values with some limitations. So, for example, if I want to drop a name column in my employees table, if I want to drop a name column in my employees table, and if I don't want duplicates name there, if I don't want duplicate names there is something known as unique. And I will drop a unique constraint there so that there will be no duplicacy. So like this, there are different data types. So the different constraints that come into the picture. And we will talk about all of them. So are you clear with like what are actually constraints on a basic definition? Any questions in this? Like what are constraints? Okay. So basically, constraints are set of rules. So I will give you an example now. Suppose I have my, like, is my screen visible to all of you? I think it's visible. Suppose if we have an employee table, and in that employee table, there is a name column. So if I don't want, uh, if I have a name column, and name column has a data type char 10, and I'm going to drop some names in my name column. So if I don't want my names to be duplicated, I only want single occurrence of every name, then I will use a constraint unique there. So if I have used a constraint unique in my name column, so every time when I'm dropping some values in my name column, so for example, if you dropped a first value Puja in your name column, and in the second row, you are again inserting the same value Puja, it will give you an error because you have specified a constraint unique there and you are dropping the same name there. So it will give you an error and you will not be able to insert a, a different record for Puja at the same point of time. So this is something known as unique. That is like, this is something known as constraints that are applied on your column values. So I will tell you different constraints that are there in SQL. So first we'll talk about not null. So first constraint is not null. So what do you understand by null? What do you understand by null? What is null? For example, I have given a name column and I have given a name column memory of varchar 20. I have taken my name column and I have given it a memory of varchar 20, which means that my name column, for every occurrence of name in my name column, it will get a memory of 20 characters. But for some reason, I have nothing in my name column. I have nothing in my name column, which means I have a space. I have a space of 20 character, but there is nothing inside that space. So null is basically known as empty space. Like a space where there is a memory, but there is nothing inside that memory. That is known as null. You can call null as empty space. You have a space, but you have nothing inside that space. So that is known as null. So the first constraint is not null. So if you are giving any column a constraint as not null, then you cannot leave it empty. You have to put something there. So if you are giving a not null constraint to your column, you have to drop something there. You cannot leave it empty. Now, after not null, the second constraint is unique. So if you are giving any column, a unique constraint, then you cannot pass duplicate values there. Duplicates there. So if I am passing a unique constraint in my name column, I cannot pass duplicate constraints like duplicate names in the same column. So if I have passed Durgesh once, I cannot pass Durgesh another time. After that, unique. The third thing that comes into the picture is default. Now, what is default? So suppose if you are creating a table and if you have given a constraint age, like for example, there's a column age, and in that age column, there you have given a constraint default. So once you are giving a default constraint to any column, you have to pass a default value as well. For example, you have passed a default value 20. Now, what will happen is at any point of time, if you are not entering or you forgot to enter your age in the column, it will give you a default age of 20. So default is something, if you don't have a value there, if you forgot to drop a value there, it will give you a default value of 20 in that column. So default is your constraint number 3. Are you clear with default? Now, the fourth constraint that comes into the picture is check. Now, if you want to check something, for example, I have a age column. Okay, Vivek will tell you about default once more. So default is something, for example, you have created a age column. And in the age column, you have passed default as a constraint. So now, when you will pass default as a constraint, you have to pass a default value in the same time. For example, I am passing age column and I am giving a default constraint there. I have to pass the default value as well. So every point of time, if I miss to drop my age value, or if I don't want to write my age value, it will give me a default value of 20 there. So default is something in place of something. If in place of nothing, you will have your default value 20. When I will give you practical examples of all these things, you will understand everything. Don't worry. This is just a theoretical part. In the next step, I will explain you each of them while creating a table. So now after default, there is something known as check constraint. So for example, I have given a age column. And in that age column, I have given a check constraint. And inside the check constraint, I am passing age greater than 18. So when you are actually creating that table, and when you are passing some value in the age column, if your value in the age column is less than 18 or 18, you will get an error, because it will tell you that you have dropped a check constraint and you have given age greater than 18. So you cannot pass a age less than 18 or 18. So check constraint is like that. It will check the value that you have passed. It will check the value that you have passed. Till here, everybody is clear? Now we'll talk about two main constraints. The first one is primary key. Primary key. What actually is a primary key? So suppose there is a classroom in which there are 50 students. And in 50 students, there are 4 students with the same name, Durgesh Yadav. There are 4 students with the same name, Durgesh Yadav. Now, the teacher was giving mark sheets to the students. So teacher was giving mark sheet to the students. And she called Durgesh Yadav, come here and take your mark sheet. How many people will go towards teacher? If she is saying that, Durgesh Yadav, come and take your mark sheet, all 4 will go there. All four will go there. Now, teacher is saying that, like, you all 4 are coming there, coming here. Not the students are getting confused, like whose mark sheet it is. So what can be a definite thing to identify a single Durgesh Yadav? If you are talking in the terms of classroom, there is something known as roll number. Even if the name of all 4 students is Durgesh Yadav, first Durgesh has a roll number 1 and all the others have 2, 3 and 4. So now if teacher is calling roll number 2, then how many people will go towards teacher? Only one, because this time Durgesh Yadav knows that I have a roll number of 2. So only I will go there. If she is calling by name, then all 4 will go there. But if she is calling by roll number, then only a single Durgesh will go there and take the mark sheet. So primary key is like a roll number. Primary key is like a roll number. So primary key is a key which uniquely identifies a row in a table. So primary key is the key that uniquely identifies a row in a table. So it's a unique identification of an entity. Now there are 2 conditions that comes with primary key. Primary key can never be duplicated, which means primary key will always be unique. So for example, if I have a roll number of 1 and my name is Durgesh Yadav, and if the other person's name is also Durgesh Yadav, he will not get the same roll number. He will get a roll number 2, 3, 4 or any other roll number. So primary key is always unique. It's not duplicated. And second thing, it's always, say it can never be null. So it can never be null. I will give you an example why it can never be null. So for example, there is roll number and there is name. And there are 4 names, like 4 same names, dy, 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 and again there is dy. Now, for example, this dy has a roll number 1, this dy has a roll number 2, and all these 2 dy's have nothing. They are empty spaces. Now tell me, if I will call Durgesh Yadav, like Durgesh Yadav, come and take your mark sheet. These 2 people, all 4 people will go. But for example, these 2 people know their identity. So they can be called by their roll number only, roll number 1 and roll number 2. But again, these 2 people don't have anything to uniquely identify themselves. Again, the same problem will be there. So you cannot, if you are making something as your primary key, you have to give something there. First thing, you can never leave it null. Second thing, it will always be unique. So that is something which is known as primary key. Is everyone clear till here? What is the primary key? So this is actually known as primary key. Now, if you know about primary key, then tell me what is the difference between primary key and unique? Both are constraints. And what is the difference between unique and primary? So unique can be null as well. If you are passing any column along with the constraint unique, it can be null. It can be null also. It will not get duplicated, but it can be null. So, for example, if you are passing, if there is a name column, and in that name column, you cannot pass duplicate values. So you have given a constraint unique to your name column. Unique. Now you are passing null value here, then A, then B, then C. Now you will think that this is also null, which means it's duplicated. What you will say? You will say it is also null, it is also null, which means it is duplicated. But listen, it's not duplicated. So if there is null and there is null, it's not duplicated. So unique key can be null as well. And you will not count that null as duplicated value. So that is the main difference between primary key and unique key. Primary key can never be null and unique key can be null. Is everybody clear till here? Is everybody clear? Okay. Now the last constraint that comes into the picture is foreign key. So what is a foreign key? So suppose there is a table ABC and there is a table DEF. In table ABC, you have a column A, which is a primary key. And in that column, there are values 1, 2, 3, 4. And there is a table DEF, which has a column B. And the column B is foreign key. And this column B foreign key is referencing to the tables ABC's primary key. So foreign key is basically a reference to a primary key column of the primary table. So if I have two tables, ABC and DEF, and I want to establish a relationship between table ABC and table DEF. So what I will do is I will make primary key to column A in table ABC, and I will pass a reference in table DEF with the name column B as a foreign key. So basically, this column B is a reference of ABC's table primary key. So tell me, if column DEF, if table DEF has a column B, which is reference of a primary key in the ABC table column A, tell me, if I will pass here 9, 10, will I be able to do it? How many of you think I can write 9, 10 here? I cannot write. I told you this column B is referencing to this column A of primary key. Okay, I will repeat it once again. Suppose you have a table ABC in which there is a column A, which is a primary key and having value 1, 2, 3, 4. Now there is a table DEF which has a column B. So now you want to establish a relationship between two tables. You want to establish a relationship between ABC and DEF. Now, if you want to establish a relationship between ABC and DEF, you have to make a relationship of primary key, foreign key. So primary key is basically the parent table here. Primary key is basically the parent table here. So in the parent table, there is 1, 2, 3, 4. And the same parent table is referencing to the column B of which is a foreign key. So now, if this column B is referencing to column A of ABC table, which is a primary key, can you drop 9, 10 here? You cannot drop 9, 10 here because 9, 10 is not a part of parent table. And you are referencing to parent table only, which means you cannot pass 9, 10 here. If you want to pass, you can pass 1 here, 2 here, 3 here, 4 here. These are the values that you can pass because these are the same values that are referencing to a column of ABC table. But you cannot pass any other value, 7 or 8. Because 7 and 8 are not a part of your primary key in the table ABC. And you are referencing the same table column DEF as a reference thing. So just understand, this is the parent table and this is the child table. In the parent table, primary key column is there with 1, 2, 3, 4 value. And in the child table, you are referencing the same column A as a reference to column B. So you cannot have values different from primary key column. You can have the same value. But yeah, you can do one thing. You can have duplicate values here. You can have duplicate values here. You can pass 5n number of times, 4n number of times. that you can do, but sorry, not 5. You can pass 4 n number of time, 1 n number of time. That you can do, but the values will be referencing to the primary key only. So if I give you an example, a good example I will give you. First, we'll understand what actually a primary key is, foreign key is. Foreign key is a key which destroys all the actions, or will give you a different thing. Foreign key is used to prevent the actions that destroys relationship between two or more than two tables. Now we'll again explain you the last time. This is the definition. So suppose you have created a table ABC in which there is data of your 100 employees. You have 100 employees, and those 100 employees data has been stored in table ABC. And there is an employee ID of all those employees. So there is an employee ID column in which there are employee IDs of all those 100 employees. And that employee ID is primary key. Now, this is the like employee table. And second table is your department table. Suppose DEF is your department table. And in department table, suppose, now just tell me, your employees table has data of 100 employees. So in your company, only those 100 employees will work in some department, na? Can an employee with employee ID 101 can work in the department table? Or an employee with 102 ID can work in that table? Suppose they have employee IDs from 1 to 100. So all the 100 people have employee IDs from 1 to 100. So in your same company, in different department, can a person with employee ID 101 can work? No. So that is the thing. Foreign key is used to prevent the actions that destroys the relationship between two tables. So suppose you are in a relationship. So I am in relationship with my girlfriend. Just take an example. And I want to be very sure that my girlfriend, is not talking to anyone. So what I will do is, I will insert a chip of foreign key to my girlfriend's phone. I will drop a chip of foreign key to my girlfriend's phone. So for example, if we have 15 common friends, and if my girlfriend is talking to those 15 common friends, then it's fine. There is no relationship, there is no destroy kind of thing in the relationship. Once my girlfriend is talking to a 16th person, that is not in my dictionary. The person that I don't know. So once she will talk with the 16th person, I will get an error that she is talking to a different person. And that different person is not in your dictionary. So that is something known as foreign key. So foreign key is a key that destroys the action, that prevents the action that destroys the relationship between two tables or two entities. I think it's clear to all of you. So that's all for the class today.